process. So these are the steps to perform the seismic design. First, we have to see the performance requirement of our structure. Then we will to assess the ground condition. Then we have to see combination of seismic action that we will cover. Then we have to see the criteria for structural regularity. Then we have to perform seismic analysis, for which we have various methods such as lateral force method, then response spectrum method, and Pushover method, and time history analysis method. Then after that we have to check the safety verification. Then at last we will see the capacity and detailing. So these are the some of the method using which we can perform the seismic analysis. So this is the static method and this is are the dynamic method. So in the static linear analysis method we have lateral force method, and in static in non-linear analysis method we have Pushover analysis method. Then in case of dynamic linear dynamic analysis method is response spectrum analysis method. Then we have non-linear dynamic analysis method, which is time history analysis method. So now let's discuss each step in detail. So first one is the performance requirement. As per Eurocode, there are two levels of seismic design and which related to the two following requirement. First requirement is a no collapse requirement. So as per Eurocode, the structure shall be designed and constructed to withstand the design seismic action without local or global collapse, thus retaining its structural integrity and residual load bearing capacity after the seismic event. So as per this requirement, during any earthquake event, structure can have a local collapse, but it should not completely collapse. And this requirement is prioritize human safety, and second requirement is a damage limitation requirement. As per this requirement, during any earthquake event, structure should not have a local collapse and it should not require any repair after the seismic event. So we can say that first requirement is focused on the human safety as a priority, and in a second requirement, it prioritizes the occupant comforts and economics. Also, in the first requirement, structure can have a local collapse, but in second requirement, structure should not have any local collapse during any earthquake event. So now next one is a ground condition. Based on the table given in the Eurocode, we have to select our soil. So based on the description given and the parameters, we can select our soil type A, B, C or D. We can select from this table given in the Eurocode. So now next one is the mean return period. Assuming a Poisson model of a occurrence of an earthquake, the formula given in the Eurocode is this formula. In this formula, TL is a reference time period and P is a probability of accidents. Earlier we see two requirements, and as per the first requirement, if we assume 10% probability of accidents in 50 years, we will get mean return period as a 475 years. And as per the second requirement, which is related to damage limitation, and in this case, if we assume 10% probability of accidents in 10 years, we will get mean return period as a 95 years. So as per our performance requirement, we can find the mean return period. So now next one is the importance factor. So as per our structure, we can find the importance factor value given in the code. So if we have building of a minor importance, we can take importance factor as a zero point 0.8, and if we have ordinary building, we can take importance factor as a 1, and the building which has a more importance such as school assembly halls, we can take importance factor as a 1.2,